And now we're down to our last topic, which is very related to beer. We will be talking about the packaging of wine. So before we go into that, okay, you might be wondering, what about the other kind of alcoholic drinks for those of you who are always drinking and partying? Okay, so here it is. Okay, it's not in your book, so I found it in the internet. Sorry, I don't have the source, but it's a compilation of the different types of alcoholic drinks. So we have wine, which is based on fermentation of fruit; beer from the fermentation of starch, like grains or your malt or barley, malted barley. We also have the term spirits, if you're familiar with that. That would be distilled wine or beer, which is stronger. We have vodka, which is spirit, which has been further diluted. We have gin, which is vodka that has been redistilled. Okay. Then we have here tequila and mezcal, okay, from a certain plant in Mexico. Champagne is sometimes known as sparkling wine, so that means it has carbon dioxide on it. Brandy is also derived from wine. We have rum. Rum is made from cane sugar and whiskey, like our scotch and bourbon from fermented grains. Now, of course, there will be variances in their packaging needs, but the most common one, I think, are just beer and wine, okay? So the rest would be either very similar or with a slight difference in their packaging needs. So let's talk about wine. So wine, what is wine? Wine is a beverage resulting from fermentation by years of the grape juice with appropriate processing and additions. So you fermented your grape juice in years, and then you just add more some certain processes and additives, okay, or other ingredients. Now here's the ultimate question we always ask: do wines improve with age? Now the answer to that is it depends on the wine quality. Some wines does improve with age, but there are other wines, and most wines are really just wine for commercial retail already. So most common wines only improve a few months or years, but after that they started to lose quality. So this question is very important because after all, if the wine does not degrade in quality, then why do we need to learn about its packaging? Okay, but then here we see that the wine does degrade in quality, hence packaging should be learned in order to preserve that shelf life of wine. So wine is a beverage resulting from fermentation by year again. Okay, I just okay, the definition again. And there are two major groups of wine. We have the table wines and the fortified or appetizer wines. What are they? Okay, let's start with table wines. So table wine is wine wherein sugar has been consumed so that further fermentation is prevented. So sugar is completely consumed and spoilage should not occur if it is kept anaerobic. As long as you did not open that or there is no oxygen that came in, it will actually continue to preserve its quality. The alcohol content is around 12 to 14%. There are two subclasses of table wine. You have the still wine. Again, when you say still, it's the regular wine, no carbon dioxide gas. And you have the sparkling wine, like your champagnes, wherein carbon dioxide is along with it. That is why for these kinds of wine, they pop up. Okay, I think you've seen that in ano in movies. Okay, the champagne pop, the cork popping out of the champagne. If it's still wine, that will not happen. Okay, okay, you need carbon dioxide or internal pressure. There's also a cool way to open your champagne, which actually includes being messy. That's called saber. Okay, where you use a sword to open your champagne. You let the sword slide down along its neck, and then it will break and then pop out of the wine. You could check the internet for that. It looks kinda badass, if I may use the word. Okay, next we have the fortified or dessert or appetizer wines, the second category. It has more alcohol compared to the table wines at around 15 to 21% alcohol, and under it there are three major subclasses. We have sweet wines, okay, we have sherries, and we have the flavored wines. So how are they made? So again, we're not going to talk much about the processing, but it looks like this. You harvest the grapes, you crush them, and in some countries, they actually crush the grapes by stepping on them, literally. Okay? So I think you're familiar, you've heard that, okay, that they actually step on it with bare feet. Although in some countries, it's not bare feet, there are specialized shoes which help in crushing them. Then they are fermented, pressed, and placed in caskets or casks or barrels for aging. and then prior to packing, some more processes, and finally bottling. So how do wine deteriorate? It's very similar to beer, oxidation. So the major derivative in white wine, okay, we have to separate another category of wine, the white and the red one. So in white wine, it's primarily caused by oxidation, leading to browning leading to browning and undesirable flavors. We all know white wines are those wines wherein the skin of the grapes are not included, okay, in crushing. But in red wines, because the skin of the grapes are included and they are red, the oxidation in red wines involves actually color loss due to the condensation, polymerization of its pigments like tannins and anthocyanins. So this results to loss of pigmentation and changes in color. Let's talk about the packaging. We have glass, bag-in-box, plastic bottles, metal, and others. And by the way, if I may add, since wine is a luxury product, okay, it's maybe it's allowable. There's a certain uh, allowable limit for packaging designers to actually make fun with the packaging, be creative, because the product category by itself is an expensive or luxury product. So like these pictures here. Let's talk about glass again. We all agree it's still the good packaging for our beverages in terms of preserving the quality. So the common packaging for wine is the glass bottle seal with a natural cork. So oxygen may again come from residual oxygen from the product, from the headspace, and from the closure itself. Because again, the glass bottle here is impermeable. So it's either from the product, the wine itself, from the headspace, or from the closure. So generally, a 15 millimeter headspace is maintained. So it's also there to prevent the cork from popping out. Okay, because of certain conditions like increase in temperature, which could increase the internal pressure. So you need a little bit of headspace. If there's no headspace, maybe there is a tendency or a risk of the cork popping out. Now, another thing, many types of wine are damaged by sunlight. Sorry, it should be by sunlight. So bottles are usually colored glass. So common for wines are dark green or brown. Okay, for beers we don't want the green, but for wines common actually ang green. Wine is stored horizontally also to moisten the core so it gives better protection and sealing properties. And for the sparkling wines, we have to consider carbon dioxide. So we've talked about oxygen as the major deteriorative reaction. But for those wines with carbon dioxide, like our champagne, you should also consider the loss of carbon dioxide. So this is almost similar to our carbonated soft drinks packaging needs. This is not in your book, but I think this is worth noting. We have here, this is very common in our wines nowadays. Other than the cork, they also have the capsule, okay? A tin lead or a tin capsule. So there's a wine there that sometimes there's no cork there, okay? It's just a regular cup and then the capsule. Okay, the capsule there acts like a tamper evident feature. At the same time, we also know that it also hides the feel level of our wine, since wine is expensive and you could not always assume, or we cannot always achieve the constant volume and constant level. So it's being hidden. Okay, the level is being hidden so that consumers will not compare one bottle from another. So here are more examples of extremely extravagant packaging of wine. We have wine with LED lights, and we have wine which changes its costume. So those are it. Okay, the next type of packaging material used is the BIB, or the bag-in-box design. So it's a film closure, it has a film, it's a closure or a tubular spout, and sometimes there's a box or a secondary container. Okay, so there are different types of laminates. So it really depends on on the company. Although the first material that was used was PVDC coated PA and LDPE. So that would mean PVDC would be the one giving your barrier, PA will be the one giving your mechanical and physical properties, and LDPE would be your sealing. So this would be the other uh, laminate construction. So we have the EVO PA LLDPE. So EVO here would obviously be for oxygen barrier, protect it. Okay, PA for the strength, and linear low density polyethylene for the sealing layer. So you could actually mix and match depending on the market availability of the materials. Another thing to consider when you put wine in the bag is the strength of the bag, since it's liquid and it's usually heavy. So physical strength is a major consideration here, and under normal situations, the bag is subjected to two forms of stresses. This is not in your book, I think, but this is actually discussed. So hydraulic shock is the caused by sudden deceleration or acceleration of the pack. For example, it's stored in your trailer in the truck. It's being delivered from the factory to the retail store. Then suddenly, while the driver is driving the truck, cat crossed the road, and then let's say a chicken crossed the road, and then the drivers brake so suddenly. Of course, the sudden shock would put all the packaging to one side, and that could cause hydraulic shock. Okay. The other one is flexing. This is caused by vibration of wine affecting the pack. So as the truck goes around transportation or in whatever transport vehicle that is, of course, it's always vibrating. And if the vibration, the frequency of vibration will now resonate with the frequency of your liquid or of the wine, okay, then it will also resonate, and that could actually vibrate the packaging, and it will affect. Repeated vibration will flex the pack until flex cracking occurs or pinholes will occur. So you really have to consider that. More or less, for flexible packaging, there's always a certain lifespan. Okay, it will not forever hold. If you're going to vibrate this forever, it will really break. So just consider that. So make sure you use those packaging materials which could resist certain shock and flexing. Okay, other than physical properties, also consider the oxygen permeation. It's the major deteriorative reaction or index of failure that we have. So again, O2 permeates the bag through the film itself, so through the film, material of the top, and the gap between the top and bag. Now, studies have shown that actually most of the ingress of oxygen entered the product through the top. Okay? Usually the material is actually good. Usually we use VM, okay, vacuum metallized or aluminum foil. But for the top, it's more of a challenge because we're using a lot of plastics, and of course the area between the top and the bag. So that's where most of the oxygen actually came in and came into the packaging. Of course, for bag-in-box, generally shelf life is shorter, but this is actually preferred in some occasions, especially since they are portable and you could just readily drink your wine if you feel stressed. Okay, another plastic packaging for wines are PET bottles, okay, or plastic bottles wherein PET is the most commonly used. So auto absorbers are also used to help, of course, maintain the quality. For metal, aluminum or tin plate is used. Usually, nitrogen gas is injected to increase the internal pressure for still wines. Now, take note, we use metal cans, and metal cans are actually dependent on their internal pressure to provide their strength. Now, when it comes to our still wines, they don't really have much carbon dioxide produced. Okay, that means they don't have much of an internal pressure. That is why you should inject it with other gases. So here, nitrogen here is a gas used for modified atmosphere to prevent oxygen. At the same time, it's also being used to increase the internal pressure and hold the shape and strength of the metal can. Now, since we're dealing with metal, again, the compatibility between the product and the metal would be considered. So we have enamel linings there. Okay, we can consider also the type of lining because it might be the one to affect the product. And when you fill it, what's the O2 content? It's very important. If it's gas flush, then no problem. But if you're not gas flushing and you're just using regular air, then when you seal this, there will be O2 in here inside the packaging, which we could oxidize your product. And here are some other miscellaneous packaging materials. We actually have the paperboard cartons, similar to the Tetra Pak. Okay, so the paper, alu, plastic cartons, and we have aluminum foil pouches. So that's it. At least you get an idea of how to pack your different beverages and certain examples of packaging format. So this is the end of our lesson, and this is also the end of our class in packaging, technical elective food packaging. So to end, we have here some inspiring words, okay, to balance all those memes and comical images. And this is inspired by the beverage industry, Coca-Cola. So whenever you feel bad, just remember that Coca-Cola only sold 25 bottles the first year. And now look at where they are. Look at how much they've reached. So never give up. And so thank you, class, for this semester. So we could all agree that 2020 may not be the best year, but you survived the sem. We survived the year. So congratulations for surviving the first online classes ever. Okay, yeah, purely online classes ever in CPU. So everything's gonna be all right. Go and raise a go and raise a glass and say, "Here's to the one that we have." Cheers, and I'll see you next year. God bless you.